Welcome to our second day, or our second session of our blockchain fundamentals course. I'm Virtual Nexus, Crypto Diaries from Virtual Nexus. Here you'll see on our first slide, we have basically the first stanza of the Second Coming poem, talking about how the center cannot hold and things are flying apart. That's essentially what's happening to our civilization right now, and we're talking about decentralization. All right, as always, cryptocurrencies and blockchain investments are extremely speculative and risky. The market is fraught with fraud, scams, and schemes. Do not risk anything you cannot stand to lose. All right? And the regulatory risk is high. We will never tell you to buy a specific asset or issue. However, we hope to train you to learn how to capitalize on mispricings in the cryptocurrency and blockchain market. Now, yesterday we talked about blockchain fundamentals such as the Bitcoin white paper and high-level public key infrastructure or public key cryptography. So the white paper, of course, we talked about the genesis and seed block, okay? And that's this one here you'll see on the right, that the seed block actually includes an article, Chancellor on the brink of second bailout for banks. So we couldn't be more apropos time to basically discuss this because we're doing it again, and we basically never really recovered. We'll talk about the history of fiat since we moved off the gold standard and the petrodollar and things like that in separate classes. But essentially just understand that this has been a long time coming. All right? So in that Genesis block, we talked also about, which we're going to demonstrate today, we're going to demo blockchain today. We talked about who is Satoshi Nakamoto. That is the name of the anonymous founder or founders of Bitcoin, the white paper, and the first people to stand up the Bitcoin blockchain. So there's three candidates here, David Chaum, Hal Finney, and Len Sassaman. And we said the most likely candidates would be a collaboration between Hal and Len. All right, then we talked about PKI, which we talked about basically you got your private key, which unlocks, and your public key, which locks. And we talked about signing transactions and sending tokens back and forth. Today, we're going to demo this, and we're demoing it on a famous website called coindemo.io. Now, there's also CoinDemo, BlockchainDemo.io, which we're going to do both of these today. Okay? And what it does is it demonstrates what a blockchain looks like. Okay, so the first thing we're going to do is we're going to generate that seed block. So we're going to mine that first block. Here it is. Okay, and our balance is 0. So we mine the first block, and then we go up to 100. We now have 100 coins, and this is in our new blockchain. Okay, so you'll notice it has a hash, which we're going to describe. We're going to describe that later, what that hash is. I just want you to see how the transactions go back and forth. So we've now mined it, and you'll see that, there's messages here on the second chain. Okay, and so you got to get these messages. So if you click messages, you'll see Satoshi sent over the latest block to the other node. And so now the other node basically has them, right? And they now see 100. They don't have 100 yet because they haven't synced up yet. And now you want to go here and you'll click syncing. And now we got the new block, and now they see 100 on the blockchain. We're going to show the details of this on the next one. And you'll see it has this block of 100 unspent tokens. So who has those 100 unspent tokens? Let's see. The reward went to Satoshi. So Hannah could be the recipient from Satoshi, sending 10 tokens for a price of 1 token. And the input is 100 from mining. So if we pay, we're going to pay that. And now we have to mine that block. So that transaction's been submitted. And now we're going to mine it. 1 Satoshi to Hannah. So we mine that block. And you're going to see the new block now shows the unspent tokens. Hannah now has 10. Satoshi has 89 because he spent 1 to send it and sent 10. Now 100 rewards went to Satoshi again because Satoshi solved the block. That's the basic rules of blockchain, of sending tokens back and forth. You mine the Genesis block, the node gets the 100 tokens. The person who owns that uses, let's go back to our private and public key issues here. Then, this would be Satoshi in this situation. Satoshi sends the 10 tokens. Okay, unlocks it with his private key, signs it with the recipient's public key, and then the receiver, Hannah, gets those tokens. That's that. That's the basic process of sending tokens back and forth. Are there any questions so far?
Well, yeah. Can I see it again?
Yes, absolutely. You want me to start from the beginning? You want me to start from the beginning, or do you want me
Well,
to?
let's just walk through it once, and then
Okay.
let's keep going. But if we can go through it again, that'd be cool.
Okay. So Satoshi mines the initial block here. He gets 100 tokens, right? I'm gonna make it bigger. Is that better?
That's a little better, yeah.
Yeah. So Satoshi mines the first block, gets 100 tokens. Then he sends some tokens, right? Right here. Okay, he sent them to Hannah. He sent 10 tokens for one, and then he submitted it, right? All right. And then he basically paid. Okay, now this is insufficient because Hannah's trying to send tokens here. So let's go back to Satoshi here. Go back to Satoshi, recipients. Okay. 89 from Satoshi, right? And you can send it again. He sent 9 here. Let's make it 10, right? And then he can pay. So he pays it to Hannah again. And then we have to mine it. You see, the transaction's been submitted. So this is what's submitted to the blockchain network. And miners have to collect transactions to create a block. So you say, I'm going to use that transaction. And then you can actually do two. Watch this. We can go to Hannah and the peer. She can send to Satoshi. She's going to send 5 to him for a fee of 1, right? And then it's going to use her $10 from Satoshi. And then she's going to add that as well. And then she can put both transactions in that block and she can mine it, right? And now that block's been mined and you're going to see both of those transactions in it. She sent 10. All right. So Satoshi receives 5 from her to him. Hannah has 4 left. Hannah pays a 1 token fee. And then Hannah got the block reward this time because she mined it. Does that make sense? Let me make that bigger again. You want me to explain that again? The second one?
Yeah.
Yeah. So what happened on the first one is Satoshi essentially mined 100 tokens right here. See that, right? Mined 100 tokens. You follow that part, right? Then he sent 10 tokens to Hannah, has 89 left, and 1 token spent. But because he mined the block, he got 100 tokens reward, right?
Yeah.
So how many tokens does he have left now?
Well, he's got 160 less 1, less 89, less 10.
Let me show you again here. He had 100 initially.
Yeah.
He spent 10, which puts him at 90.
Yeah, 90.
He spent 1 for the transaction, which puts him at 89. And then he got 100 left.
Yeah.
He should have 189. Okay, is how many he should have
Okay,
left.
yeah, there you go.
Right. And then she should have how many?
Whatever
10.
Satoshi
10.
sent her.
That's right, 10. Then in the next block, she sends 10. So she sends, Satoshi sent her 10. Let me get this straight. Satoshi sent her 10. That's what you were getting at earlier. And so now he has 10 left, 10 less. There's a change in his initial one. There you go. She sends him 5, or she sends 4, pays 1 transaction. So she has basically 5 left. But she got 100 in rewards, so she has 105 because she mined the block. Okay? So
Who's handing out these rewards?
What's that? The rewards is the block reward for each time you mine a block, right? So in Bitcoin, remember the mining rewards? That's what that is.
This isn't Bitcoin, though, is it?
It's the equivalent of it. It doesn't matter. We could have made the mining reward anything, right? We could have made the mining. No, it would be no. They're getting a ton more than that. What's the current block reward? Let's look it up. Okay, current BTC block reward. There it is. See, look, and there you go. 6.25. There you go. Per block.
Yeah.
Right, and that's how a miner makes money, which we're going to show that in a minute. Okay, we're about to show how they actually make.
Are we talking about Bitcoin, or are we talking about a for instance?
This is a for instance.
Okay.
It's an illustrative case.
All right.
All right. So that's essentially how tokens are sent back and forth and how they're earned. How are the initial tokens created, Todd?
How are they initially created?
Yeah, how? Like what actually? What's that?
Are we talking about Bitcoin?
Yeah, anyone in any blockchain in general, but Bitcoin specifically is what we're using as our example.
Well, Bitcoin is mined.
Mined. It's the block reward. So all tokens initially come from a block reward. That's from mining. And eventually Bitcoin will run out of block rewards in like 100 years or something. But it goes down to like 1 token a block, like in like 2 halvenings, right? It goes down really low, right? To near nothing. And that's when transaction fees have to get higher. We'll talk about that some other time. That's going to require an entire course, just that one thing.
Yeah, either Bitcoin price is going to have to go super fucking high, or the electricity price is going to have to be almost free.
It's going to have to be all those things. There's no way to do this, which we'll talk about, because it has to be expensive enough that it doesn't pay to abuse the system, which we're not going to talk about. All right, so the initial reward was 100. He sent 10 to her, spent 1 to send it, and then got a $100 reward because he mined it. Then she sent 5 to Satoshi, added his transaction to, and mined it, and so she got 100 there. That's how they get sent back and forth. As I said in PKI, basically she unlocked it with her private key, signed it with his public key, and sent it to him so he can unlock it on chain. The Bitcoins only exist on chain. They don't ever go anywhere. This is the hardest thing to understand. I remember this. Where is those Bitcoins? Like if I turn the computer sideways, I used to think, if I tip it over, like the coin's going to fall out. Are they in my Bitcoin wallet? They're not, which is why we're going to talk about this. The Bitcoin wallet is not a wallet. It's a keychain, right?
That's right.
The wallet is on chain, and it's on in every block. I know I'm getting all lit. I get all crazy.
I thought they come out the USB drive.
Right. That's what I thought, right? That's what everybody thinks. Now do you understand why they don't get it?
Obvious.
Everybody thinks that. And it took me years to get it. Or as my mom used to say, being Indian, years. Me and my brother used to joke. We'd be like, how many years have you been working in a doctor, Mom? Oh, 18 years. And we go, hee, hee, hee. We would laugh. So whenever I say ears, it's my mom, her Indian accent. Yeah. And my brother's was Virginia. So when he moved to Georgia, we're like, wait, where's the capital? Northern Virginia. We said, Virginia, huh, Pa? No, you guys made fun of me because I'm a dumb Indian. He would say that just like that. We would all laugh in the car. The beauties of family. Miss my pops and my moms. Yeah. I'm just a dumb Indian. Yeah, it was so funny. My dad's a genius too. So, all right, that's the basic idea. Now we're going to add complications now. So here's the complications. This is blockchaindemo.io. Again, the first one was coindemo.io. The second is blockchaindemo.io. It comes from Free Code Camp. They created these demos. Now, I've written these demos before for a class called Chain Shot Bootcamp by a guy named Dan. I can't remember his last name, but it was the most amazing class. Guy's a genius. Brilliant guy. So now we're going to do the demo, okay? So the first thing we're going to do is this one has a peer-to-peer network and new explanations, blah, 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 and source code. Doesn't matter. Okay, blockchain is a list of blocks. It starts with the Genesis block. Here it is right here, okay? Now, it uses what's called a hash, which we're about to describe, okay? It's got an index. The hash has an index, a timestamp. So the index is what block number this is. So what block index is this? 0. The timestamp is
0.
Yep.
Genesis is block 0.
Yep, it's 0. The timestamp is whatever. Okay. The hash is the hash of the block itself. That's all the binary or hexadecimal numbers. They perform a mathematical operation. They divide it, they square it, they root it, they slice it, they dice it, they broil it, and they get this resulting number. A hash is basically a hashing function takes an arbitrary length of data and then adds padding to it and a nonce, and then when the math results in a same length hash. That's what a hashing function has to do. Every hash that comes out has to be the same number of characters. So the mathematical operation is such that it increases it and makes it into the same result. Now, some things about hashes. Let's go to the next one. So the index is the position of the block in the chain. This is a Genesis block. It has an index of 0. The next block has an index of 1, okay? The timestamp is a record of when the block was created, okay? It keeps it in order, all right? The hash, here we go, has a fixed length. Same data always maps to the same hash. Different data always maps to a different hash within practical limitations. So SHA-256, which is a hashing function used for Bitcoin, for example, there is a theoretical collision. That means when two different types of data can result in the same hash. Nobody's ever computed it, but we now know that it's theoretically possible, which is hence why Ethereum uses SHA-3, okay, which is a different hashing function. All right, we'll get to that some other time. So it's easy to compute. It's infeasible to go the other direction, right? A lot of people go, how can't you reason backwards from the hash? No. The mathematical function is such that it's too difficult or it would take longer than the life of the universe. All right? A small change in the data leads to a large change in the hash. There we go. A valid hash for a blockchain has a number of leading zeros. That is the difficulty level right there. See those zeros right there? That's that. Those first three. The more number of nodes and the faster that they get, the more that difficulty level rises. Okay, this ensures, based on the protocol, that every block takes approximately 15 minutes. That's a blockchain.
Why does everybody say it's 10 minutes?
It's 10 minutes plus or minus an offset of 5, I think. Let's look that up. So let's look at Bitcoin, right? Bitcoin block times. 10 minutes. There you go. So it's 10 minutes. Excuse me. I stand corrected. There's an offset in there. Let's see what the offset is. So it averages out to 10 minutes. There's the important piece of information. Oh, my computer's making a lot of noises.
So the difference between 10 minutes and the hour that it actually takes me to do a transaction on the Bitcoin blockchain is what the stack of transactions waiting to get through. Is that what that is?
No. There's a random nature of block solutions. 50. Here it is right here. Let me make it bigger. Okay. So 15% of blocks will take longer than 2 times the target, 3% longer than 3 times the target, right? This is all math. It's basic arithmetic that determines that it's going to increase or decrease based on a random variability, okay? The main thing is, though, over a period of time, right, and many blocks, it's going to average to 10 minutes. That's the point, right? I was wrong to say 15.
There's your 15.
Yeah, which is what I said. Wait, you see 15? Yeah. Okay.
That's your number 15. That's where it comes from.
Yeah.
You must have read that before.
Oh, of course. No. Yeah, my brain is, you have no idea. Like, it's a mishmash of just rando.
All right.
So, yeah. It's because there's dozens of blockchains. We're going to talk about consensus in a later class and different types of consensus, such as proof of work, proof of stake, directed acyclic graphs. There's all these different ones. And you can be certain Bitcoin proof of work is probably the worst one. All right, so we'll get back to it. So the number of leading zeros determines the difficulty as the hash rate goes up and the number of nodes. All right. So the block hash calculation includes the index plus the previous hash plus the timestamp plus the data plus the nonce. Okay, so watch this. 0, right, is the index. It's block 0. The previous hash is 0. The timestamp is this is a Unix timestamp, which we're not going to get into what that means. And that's the data plus the nonce equaled this 0. Watch this. If I change the data, it's no longer valid and I have to recompute it. I'll press the tool button. There you go. It's now recomputed. Okay. If I and then look, the nonce is different to get a 0, but watch. If we put an exclamation point in there, it's not 604 anymore. Why? Because the timestamp is different, right?
Right.
You see that? So each of these change.
Yeah.
It's not 300 and whatever because the timestamp is different. Let's do it really fast. No, it's not going to matter. You get the idea. Small change in input creates a huge change in output. So let's continue our demo. Okay? All right. So now the previous block's 0. We already went through that. Okay, now it wants us. Okay, each block can store data in there. In cryptocurrencies, the data includes money transaction. And remember ordinals? That's where your ordinals are going in the data, right? Because the data is not entirely used in the block. And so they were going to put ordinals in the transaction, actually, not in there. It'll be in the transaction messaging. So let's just look that up real quick. Ordinal data BTC TX. Inscriptions here. We're not going to get into this, right? Ordinals are individual sats, okay? And so basically you can assign data to the Satoshis, which is Satoshi is the smallest unit of, I probably just gave up my firstborn child there. Sorry, buddy. We just click that agree and we don't even read it,
Yeah.
Yeah, and I always pick, you know.
You're going to prison now.
Yeah, probably. Yeah. So anyway,
Suddenly
they talk
you're
about
no knock raid at your house in 5 minutes.
seriously get swatted.
Yeah.
Okay, we're not going to go through all those ordinals because we want to stay on task here. We're already going kind of long. All right, so each block has data in there. That's the data block. And now, right, the nonce is the use to find a valid hash. We already went through that, right? So that number down there. And nonce stands for number used once. Okay, all right. Mining a block. Okay, as the difficulty increases, the number of possible valid hashes decreases. With fewer possible, it takes more processing power. If the hash on the block is invalid, you got to click on the tool to remine the Genesis block, which I already did. Remember, you saw me do this, right? I basically took that out. It was invalid. I remined it. There you go. Put it back. There you go. So that's important. So now it's going to want us to add some more blocks. It's going to want us to add 3 blocks. So now it's going to tell us add 3 blocks and then mutate the Genesis block. It wants to show how it invalidates all the other blocks. So what we do here is I add another block. We're going to call this block 2, right? And then it's a valid hash, and then we're going to add block 3. Okay, that's the data. All right, now I'm going to change this first one, right? And then that's not going to, oh God, they're all invalid, right? Because then this hash has now changed to an invalid one. That one's invalid. All 3 are invalid. This is why the blockchain is considered immutable.
Yeah.
The code itself is not, but the chain itself is. That's the chain of blocks. So we got to recompute that. Then we have to recompute that one. And then we got, so it took a little longer, and then we recompute this one, right? You can change one in the middle, right? And that would be a problem, which we're not going to do. All right, now we screwed it up, right? It's like, oh, sorry, so we got to redo it, and then we got to redo that one. All right, now it's going to want us to add a peer, but let's wait and see. It says, okay, mine another block in the chain, fill out the data input, and click the button. I'm pretty sure I already did that. Let's make sure I did it. Now I went through this multiple times, but like it's kind of hokey, so I want to make sure. Okay, Okay, we had another block. I'm just gonna make that block 4. Now add a new block. Okay, adding valid blocks. We've already So now we're gonna add a peer. Let's see what we're gonna let us add a peer. So this is a peer. We're gonna add a peer in a second. Okay, add a peer. Ophelia. Who is it? Trivia. Do you know where the name Ophelia comes from? Most commonly.
Ophelia comes from, what's his name there, old Bill Shakespeare.
Yep, good old Bill, Hamlet's girlfriend. Okay, yeah. I'm pretty sure she killed herself. Shakespeare's really jacked up. Like everybody considers like Romeo and Juliet like a great play, like romantic, but like those 2 idiots killed themselves, so obviously that's a horrible, like, that's just
a lot of people would say it's a tragedy.
Yeah, it's a joke. It's obviously a comedy. Yeah. It's obviously a comedy. There's no way to... Yeah, remember how when we were younger, oh, it's so romantic. No, that's a comedy, dude. It's so ridiculous. Okay, let's continue. All right, so we added a peer, and here we go. And now you're going to see we have currently active, connected, not connected, and you can see history with the little messages, and you can disconnect. So we're going to connect to Ophelia, right? But you can see this one, what does that do? That one connects to the other one. So we're going to go back to our demo here, and we're going to follow along and see what it says. When you click it, you won't see anything because it's on that first page. All right, so we've now connected to Ophelia. We've now connected back. Okay, and now what we're going to do is we're going to ask for each other's blocks to determine who has the most up-to-date blockchain. So the next thing we're going to do, here's the flow chart. Connect to peer. Ask peer for latest block. Okay, compute the blocks and see if they match. If the peer's block index is greater than the last block, no. Okay, do nothing. Yes, ask peer for entire chain. Peer sends entire chain. If the peer chain is valid and longer, replace the chain with the peer chain. If it's not the peer's block, we append it to ours. Okay, I don't want you to get into too many of these details, so just get used to it. All right, and so now we're going to put that back down. We're going to go next. Okay, so now what we have to do is we add a peer connect, add a block, and then check history. Okay, so we're going to add a peer. We're going to connect. Okay, we got to do a connection. Okay, and you can see the history, right? So let's add a block real quick. I'm going to add a block. I'm going to call it peer 1, right? We're going to add that. Now we got peer 1. These 2 blockchains you'll see are now different. So there's a bunch of messages. Check history between peer. So that's your history button. Okay, Ophelia connected to Satoshi. Asked for the block. The block index is not longer than the latest block. Does nothing. They requested latest block. Okay? Ophelia's block index is not longer, so it does nothing. So she does nothing. If you connect to her, she still has her same 1. Now, we're going to see this update, right? So she still has peer 1 block, and of course Satoshi has got like the longer chain here, right? So now what we're going to do is we're going to follow the demo and see what it says. I've done this already, but I'm just demonstrating. After the longest chain is valid, it will broadcast its latest block to peers. Eventually, all the peers will have the longest valid chain. Okay? So now what we're going to do is we're actually going to sync. She still has peer. Oh, so we have to go here. Messages. So Satoshi's chain is invalid. Check the latest block. All right, there it is. Satoshi's blockchain is longer. Replace blockchain. Come on, let's replace it, babe. Sending Ophelia entire blockchain. Man, that took forever. Block 2, block 3, there you go. Block 4. She now has the entire blockchain. That's what happened. Okay? That's what I was trying to say. So that's how that battle occurs. And this is the end of our demo. Right? 51% attack is when a participant has more than 51% of the network. When there are more miners in the network, the power becomes more distributed, known as majority power. It's a more secure blockchain. Okay, and that's that. And we'll send him some money. You know what? I'll actually show you how to send money in the next one. I don't have my wallet plugged in, and when I set up demos like that, I have to be careful so I don't leak intel to people, right?
Right.
You know, yeah, they're like, oh, this is Karate's wallet. Oh, Karate's got $1 trillion. I obviously don't have the blockchain. It's not worth $1 trillion anymore.
Yep. You're Satoshi.
Yeah, it will be worth $1 trillion again. I guarantee you.
Yeah.
I mean, if I can't
Well,
guarantee you,
double.
no. Let me rephrase that. I cannot say that. This is not financial advice, and I am not saying that. I said it's likely to return to $1 trillion at some point based on what we've seen before, but past results are no predictor of future returns. So you would send money to this address.
Saying it'll return to $1 trillion is not financial advice. Saying it'll return to $1 trillion on Thursday is financial advice.
And buy now, yeah, you're right. But I'm still being careful. I don't want to get that on access. So that's our demo today. That's that. Okay, these are the websites: coindemo.io, blockchaindemo.io, and then there's a link in there to get to Free Code Camp to see the code. Now, I've written this code before, believe it or not, from one of my classes, but I can't remember how to write it because I don't remember anything that's written down as a general rule, right?
Right.
Like, why would I remember it? So now we're gonna switch. Okay, let me stop our demo, and we're gonna do this here.